All right, welcome. One-to-one functions continued. Last time we talked about the definition of one-to-one function and how to determine whether a function is one-to-one, and we have a general discussion and how to identify the function that is one-to-one, right? So here, from definition perspective, right, we talk about function. A function is a rule that from the domain, for each input from the domain, it produces exactly one output in the range. And we can do vertical line tests to determine if a graph makes a one-to-one function. If it is one-to function, then we could go ahead to check if it is one-to-one or not a one-to-one. And the definition for one-to-one function is that whenever the inputs are different and the output are different as well, the respective outputs are different as well. For not being a one-to-one function, that if we can find if there are inputs that are different, but the outputs are the same, which is contrary to the one-to-one function requirement, okay? So, and we worked with 4 functions, right? And we have discovered some of these are one-to-one, some of these are not, okay? And this is not a one-to-one. And this is one-to-one, 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 okay? And we have also determined, right, for the square function, x squared, it is not one-to-one, not one-to-one, right? So that was the last example we did from the previous video. And now we have 3 more functions to work with. 3 more functions to work with so far. Okay, we still have many more to work with. Okay, so now let's look at the absolute value function. Is it one-to-one? Is it one-to-one? From the graph, we can tell clearly it is not one-to-one. So let's take this out. Is this function one-to-one? The answer is no. Why? So what are the words we're going to use to express it, to convince people that we have done the right thing, we said the right thing. And we said the trick is to, cite the definition always cite the definition, right? Since from the picture, we can tell it's not a one-to-one, and thus we just have to give a reason. And since it's not one-to-one, we know for sure we just have to identify one pair of numbers. One pair of numbers. Where is it? Okay, here. We just have to identify one pair of numbers. Let me see if I can put it here. Okay, there we go. This is better. Right? For the given function, right, we know it's not going to pass a horizontal line test. Because it's not passing horizontal line test, and we draw a horizontal line. If we draw a horizontal line, right, we can actually identify many such numbers, but we only need one pair. We only need one pair. So I'm going to draw a horizontal line. Say 3, right? The horizontal line is y equals to 3. It crosses at 2 points of the curve, right? And we mentioned that what does it mean, right? These 2 points, what does that mean? When input is horizontal, that's input, and the output is red, right? Same output. For different inputs, right? So we just have to make a statement. So for x1, so we can choose x1 to be -3, right? -3. -3 is not the same as 3 for sure, but f of -3, what is f of -3? What is f of 3? Right? F of -3. F of -3, if we plug in, right? If we plug in, that's going to be absolute value of -3. Wait, sorry, I clicked cancel. The absolute value of -3. And f of 3 is absolute value of 3. They're equal. So for sum, you can remove the sum actually. You can remove the sum grammar-wise, right? For input -3 and 3, which they're not the same, but their outputs are the same. So we have made the statement. Okay, we have made the statement. Cited the definition. We have cited the definition, C-I-T-E, cited. We have cited the definition. Okay, so you can say it is not. Okay, you can say this function is not a one-to-one function because for -3, which is not the same as 3, but the output the same. Okay, you can also remove these two. You know, you can just do this too. Right? So there's some variations. You can say, you can express it, but this is probably the simplest way. So you make a connection. You really just cited the definition of one-to-one function in this case, which is the opposite of it, right? False one's false. The next one, the square root function. Is this one-to-one? Is this one-to-one? Right? Is this one-to-one? Is this one-to-one? We got the graph. It passes not only the vertical line test, it passes the horizontal line test. So it is a one-to-one function. Okay, because of what? We just have to cite the definition. So on the one hand, we apply the definition. On the other hand, we're also going to apply the actual rule of the function. So whenever x1 is not the same as x2, but we have to cite the domain here. So x1, wait, sorry. Okay, x1, x sub 1, different. So but both of them must be larger than or equal to 0 because that's to guarantee they're in the domain. They're in the domain. Okay, and the square root of them, right? When these two are not the same, right? And their square root, because f of x1 is the square root of x1, right? We just plug in x sub 1. And the other one will be x, the square root of x sub 2. Oops. Sorry. So whenever these two numbers are not the same and they're both, you know, greater than or equal to 0, they cannot be the same and their square root are not the same. And that's guaranteed, right? So this statement is true and it's one-to-one. It's one-to-one. Okay. So one more, right? One more, this last one. Okay. And last one. Is this function 1-to-1? Function 1-to-1. Well, we can try vertical line. Well, we can, I'm sorry, we can do horizontal line test, right? We know it's a function already, so there's no need to do vertical line test. But if you do both tests, you would do vertical line test first, and then you do the horizontal line test, right? And does it pass horizontal line test? Yes, it does. Yes, it does. Okay, so once again, we're going to apply the definition of function. Wait, sorry, I pasted the wrong thing. Okay, so I'm gonna copy and paste the definition of function, which is right here. You see, right? You can say because when x1 is not equal to x2, okay? And you make sure that x1 are from the domain, right? So x1 cannot be 0. X2 cannot be 0. Be aware of the domain, right? We do everything in the domain. So none of these is 0. So whenever these x1 is not the same as x2, their output, their respective output, which is 1 over x sub 1, is not going to be equal to 1 over x sub 2. Right? Because this is true whenever, right? So it is. Okay, you can say it is, right? It is that is 1-to-1. Is 1-to-1. All right. To summarize, so now we have covered all of these functions. We've covered all these functions, right? In terms of 1-to-1, right? In terms of 1-to-1, so we're going to bring all of them back, right? With us, all of these functions. We have gone over all 8 functions in terms of if they're 1-to-1 or not. So which one is 1-to-1? This is 1-to-1, right? That's 1-to-1, 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 not, 1-to-1, 1-to-1. Okay, so 8 functions. 5 out of 8, they're 1-to-1 functions. Now our next question is, if they are 1-to-1, okay, every 1-to-1 function has an inverse. Okay, so let me write it down. Guaranteed. A 1-to-1 function has a unique inverse. Okay, exactly 1. Okay, so unique means exactly 1. The question is, how do we find them? Okay, how do we find the inverse of a 1-to-1 function? Okay, so that will be the topics for next lesson. That will be the topics for next lesson. Okay. Thank you for watching. I'll see you in the next lesson. Thank you.